You'd say that's like about 10 to 15 centimeters above the orifice?
I'd probably say like 15, 20.
15, 20?
Video, you want to zoom in a bit, please?
Roger.
A little bit more.
Yeah.
Hold that. Yeah, I think a guesstimate of like 15 or so.
Okay.
Trying to guess where that mouth is of the orifice.
Actually, I think that wand is about 6 inches to the red tape. Almost 6 inches. So, yeah, that's about right. Like 12 centimeters, a little more.
It's a good indicator.
Should have put striations on that.
We have something of science? What was the crowbar of science?
Crowbar size.
It has striations on it.
Stopping sample.
Roger.
End flow counts 51829. End volume was 21.8 at 3.6 liters per minute.
IGT temperatures were mostly in the 30s and 40s, but had a high of 60 and a low of 12.85.
And Eric, are we going to be sampling a little bit lower as well again?
No, I'm gonna try to put a narrow band on the temperature and have Jessica chase it around.
So it'd be fun.
All right. Well, sounds good. Let me know when you're ready.
Will do.
Nicole, what was the name of this chimney again?
Well, the site is Mount Edwards.
Yeah, this is Mount Edwards, but it's also the microbial colonizer site.
Mount Edwards is shorter.
Yeah. So all of your samples are the dive, the S port, and then Mount Edwards for the ID. So the next one would be H1754-S8 Mount Edwards.
Okay, Jess, so we're gonna keep it about the same height, but right now it's 40 degrees. I think it's because it's wafting away from us a little bit, so if you can just push it in.
Push it further away from us. Roger.
Yeah.
More into the flow. Understood. Same height.
Good morning. We're off the coast of Northern California and Oregon at Gorda Ridge at the bottom of Juan de Fuca Plate and at hydrothermal vents. Sampling.
All right, Eric, how's that?
36 degrees. It's steady. Maybe
Do
I
you
pushed a
look
little
at
too
them?
much.
Roger. Do you mind if we look at the orifice on bubble? All right, I'm going to come back a little bit. Can't really see much there, can you? I think probably right here. How does that look to you?
38, 39. It's mostly in the 30s. Can we slide to the left a little bit?
Okay, let's try that.
Yeah, that's hotter. 65, 70. Starting sample now.
Roger. Thanks, Josh. Probably would have dropped because now the flow is now more perpendicular.
Yeah, I'm getting, well, 57 degrees, 51, 49, 50, 55. It's still in there.
Roger.
IGT's at 75.
Yeah, I think the IGT is a little bit more in the flow.
41, it's 37. Now it's out.
Yeah, so I can either bump it over or just leave it.
Bump it over, please.
Roger.
That's good.
Frozen here.
55. 56, 55, 54,
IGT's at 101.
60, 73, 77, 71, 74, 78, 69, 70, 71, 73, 75, 76, 77, 77, 84, 75, 78,
111 on the AGT.
77.
I think the IGT is just a little bit more into the direct flow.
It's also a little more sensitive.
degrees, 74.
What's the temperature range you're aiming for with this one, Eric?
Around 40 to 80.
Well, that's on the nose.
Mm-hmm. I think we're pretty on the in the flow there. I thought you were getting a little bored, so I had making chase it around.
No, that's fun.
Now, the closer we get to the orifice, the more chasing you have to do.
That is true. So you're trying to get more of a spatial resolution of how the temperature and associated bacterial communities.
For me, it's more about the fusion of flow around the site and the plume
Okay.
of how it mixes with the surrounding seawater.
Okay.
But that could also play into microbial communities.
Roger.
75 degrees. One of the things we're just trying to demonstrate right now is adaptive sampling. Because if we envision a mission on Enceladus or some other water planet, we'd be deploying a lot of sensors and not necessarily humans controlling them.
That's a fair point. It's nice that it's thresholded, so we can have some error.
Mm-hmm.
I can imagine that'll be the same for any autonomous search mission, I guess.
Yep. 75, holding steady.
Are those limpets that are attached to the cones, are those indicator species for anything in this area?
I'm not sure.
Not sure. They're very small. Are they just baby limpets, or are they always smaller at the vents?
I'm not certain, yeah.
I don't know if anybody in the van at the moment knows much about the limpets.
mollusk.
Maybe Megan does.
Just because
sorry, what was the question about the limpets?
I was saying how small they are. Are these baby limpets, or they just remain this size?
Stopping sample.
Here at the vents.
Stand by on the limpet question
Okay,
for one
sure.
moment.
And flow count 59604. And volume 22.2 at 3.7 liters per minute.
Got it. Thanks.
And the high on that was 111.61 and a low of 76 on the IGT.
Sample, that was sample 8, right?
Yeah, that was the one we just did was
That's
8.
8. Okay.
Yeah.
We're aiming for 14, is that correct?
That's the max I can take.
Roger.
The max on yours was 111, you said, Michelle?
Yep.
Let's not get any closer. I got close enough before. Let's try a source behind this flow.
Behind?
Yeah.
Roger.
So push it like 10 centimeters forward.
10 centimeters behind the flow, going towards the cones or towards the vehicle?
Towards the cones.
Towards the cones, aye. How does this look for you, Eric?
Let me check the temperature. Getting 40, 35, 32, 30. I think that's,
IGT's at 2.
yeah, it looks like it's well out of the flow.
Party on top of number 5.
I know. Someone brought the guacamole. I think that's what it was.
Starting sample now.
Roger.
What are your temps, Eric? Mine are
Getting
1
like
and 2.
3 to 5, 3 to 6.
Okay.
Eric, when there's a moment, could you please explain to the audience why you are taking these samples and how you will use those?
So I'm taking these samples to look at the chemistry of the vent fluids coming out of the hydrothermal vents, because it's very drastically different from the conditions found in the seawater around it. This will inform us on what kind of inputs into the ocean from hydrothermal vents, and we can kind of also estimate budgets from these areas, how much is input into the seawater, and how these plumes actually diffuse throughout the ocean floors.
Thank you.
How are we looking on time, Nicole?
We're about an hour behind at this point.
Okay.
Nicole, when there is a moment, could you please share the collaborative effort that's involved in bringing a team of scientists, technicians together?
Sure. I mean, this is a cruise that started in the planning phase as soon as the last subsea cruise ended. So we've been planning this cruise for 6 or more months now, holding meetings weekly, and some for the science team, and then some broader meetings for the entire team that's involved monthly. And it's, you know, it's a large effort to get scientists to just write down their goals and collaborate together, make sure that we're able to get everyone's objectives met. I think the most challenging thing on this cruise is that it's very sample intensive, and so the vehicle's fully loaded with sampling gear. We have limited space.
Stopping sample.
And so we just have to be sure that we're taking into account everybody's objectives, because we have a wide variety of scientists who are involved, from biogeochemists to engineers to seafloor mapping experts and geologists. And so we're just trying to, especially now that we've been sort of limited in dive time by the weather and by some earlier ship issues, that we have to really look at those priorities and balance them. But it's, I think it's been going pretty smoothly, all things considered.
Thank you.
Inflow
Hi,
counts were 65796. Total volume of 17.68 at a flow rate of 3.5.
Got it.
And the IGT ranged from a low of 1.84 and a high of 7.21.
Can we zoom out on Hercule a little bit?
Sure, go ahead. Video.
Okay.
What you looking for, Eric?
I'm looking for a little higher sample following the flow, so up and to the left towards the tube worms.
Roger. And it can be inflow, but up and to the left a bit higher. Is that correct?
Correct.
Okay. I'm going to push in a bit, though. The video, can you come in a bit, please?
Yeah.
Right about there is good. Thank you.
No problem.
How's that looking for Eric?
Looks pretty good. Is that as far as you can go to the left?
I can try to go a little bit more left if you like.
Maybe a little higher.
A little higher?
Just let me double check something quickly here.
Yeah.
Sure, go ahead.
Are you stuck on that marker?
No, the
No.
marker just might slide with us a little bit.
Okay.
I'm just making sure I got space. Yeah, we probably have only inches left.
Okay.
I can try going a little bit higher if that's desired by you.
Yeah, let's see if we can get us a tiny bit higher.
Roger.
That's pretty good right there.
Okay. It looks like, yeah, we're at least in the flow.
Mm-hmm. I got 7, 9 degrees, 10 degrees. Starting sample now.
I think it might be too much, guys. Video, come wide, please.
All right.
Can you come wide on Argus, please?
Yeah.
You come loose.
Looks like I've come off the station.
Full wide on both.
I'm gonna
Roger.
stop
Can
sample.
we do a ship move?
I'm gonna.
Yeah.
You can just leave the arm.
Dad, I'm gonna scrub that sample.
Another step.
Got it.
Let's do
80.
yeah 180 again.
5 meters.
Yeah.
Copy. Bridge nav.
Did you have out a heading on before or no?
No, it was not on.
Can I get another step, please?
All right. I'm actually just gonna lift this up a bit more because I think we're gonna go into the slope a bit. Okay. Now reapproach. Actually, video, can you, you're all full wide?
Yeah. Full wide.
Okay. Oh, that's this heading. Actually. Let's get right up against some tube worms here. Full now. I'm actually going to get off this clump a bit more, so my left side. There you go. Okay. All right, Eric. Looks like we're stable.
Okay, let's move it to the left more.
Okay. Yeah.
You're probably pretty close to max on your...
On the bungees,
Yeah.
yeah.
Can you pull back like just a little bit?
Pull back, roger.
Hold there.
Holding here.
Actually, you're pretty good. The blue is just at the edge, so you have another... not that much.
Yeah. Eric, is that good for you there, or are we...
Stand by, I'm checking the temperatures.
Roger. Doesn't look like there's a lot of fluid float there.
They just shift directions.
It looks like we might need to go a little bit more left. I feel like in bubble cam there's not a lot of fluid flow surrounding the probe there.
I see. Pull it back and to the left, I suppose?
I think so.
Let's do it.
Okay. Roger. This looks like it's in the flow over here. Is that okay for you?
Stand by.
IGT's at 11.
Alex, we do another ship move 5 meters 260.
5 meters at 260, copy.
Yep.
Bridge nav. Can you get 5 meters at bearing 260?
Okay, lock it out.
All right, I'm frozen here.
Taking sample now.
Roger.
That's the restart of S10, right?
Yep.
Cool.
Mine's dropping a lot.
It's alright. I think it's gonna waft around that area.
Yeah.
Higher you get, more diffuse it's gonna get.
Right.
Eric, is this still okay for you?
Yep.
Okay.
Is the bubble cam usually that shaky?
I think it's
not
probably
shaky,
just the
it's
shimmer.
just the flow.
It's
Just the...
Sarah, when there is a moment, could you please explain the role of each person on the ROVs, the Hercules and the Argus?
I can explain my role and then they can chime in with their own.
Okay.
But I'm the video engineer, so I'm here making the feed go out to the Nautilus Live and channeling which feeds go into that, into the quad and everything. And I'm controlling the cameras the main cameras on Argus and Hercules so that the pilots can see and everything is, I do zoom, iris, and focus so that we can see it properly.
Stopping sample.
Roger.
Sorry, Alex, can you do one more step? Same 5 meters, 260.
Copy. Bridge nav. Yeah, another step, please.
And flow counts 72325 for a volume of 18.6 at a flow rate of 3.7.
IGT had a temp range from 3 to 11.61.
Copy, thanks.
Jess, is there a way to move the wand further to the left, or you're at limits?
Further left,
Yeah.
towards the tube worms and a little bit in. Is that all right?
Yeah.
Sure. Should be all right. I'm going
I'll
to take
just
a look
give you
at the
that, sure.
tubes.
Let me look at where you're going.
I might keep an eye on the... It doesn't matter if we're in the flow, is that correct?
I mean, I was just trying to get something upstream.
Upstream.
So a little wafty in there. I'm
Upstream
definitely,
or
it's
to the
definitely
left?
more diffuse.
Alright.
That direction is good.
About here?
Yeah. Can you go further to left or no?
Let's take a look at the tube if you don't mind. Josh?
The tube?
Yeah, at the base of where the springiness comes out.
Oh,
Sorry.
I think you're okay there, because we're going across. You're not really pulling too much.
Yeah, okay. Eric, is that good for you here?
Stand by.
Standing by.
Got a little bit more to give there.
Roger.
It's pretty much the same temperatures as last time. How about, can you aim the wand up away from the flow? Just above all that?
Up away from flow.
Yeah. Where there's no shimmery.
So up here is what...
Yeah. Can you angle the wand upward?
Roger. Stand by.
Yeah, I'll go the other way.
Yeah. Oh yeah, it's wrapped the other way, huh?
Yeah.
So like this, Eric?
Yeah.
This your vision?
Can you do a little more to the right?
A little more right?
Mm-hmm.
Somewhere over here?
Yeah. Right there.
Right there. Roger. Locked in.
The marker thinks everything is A-okay.
Marker's being a little buddy.
Herc, is it okay for me to relaunch HIPAC survey in order to load in
Starting
new
sample.
targets?
Yeah, I think that's right. I don't think that'll affect any of my auto, so. Go ahead.
For those tuning in, we are off the coast of Northern California and Oregon at the bottom of the Juan de Fuca Plate at Gorda Ridge, sampling hydrothermal vents for subsea, NASA subsea, Woods Hole Oceanographic Institute, and NOAA, and of course, Ocean Exploration Trust.
Would you guys say it's about 90 to 100 centimeters above orifice? Maybe more?
Let's see here.
Yeah, I'd say it's at least a meter.
At least a meter?
Yeah, probably a little more.
Yeah, and we're not directly over the hole.
We're further away from the hole, right?
Right.
Okay.
We're further towards those cones than we are towards the vehicle. Rather, sorry. The orifice is closer to the vehicle. The wand is towards the cones.
So how's it going, guys? Are we still super sampling?
We are.
Cool.
Indeed.
A is for analysis.
Yep, I was off exploring by the seat of my pants.
Very cool.
Wow.
Yeah.
How's that going for you?
It was my first time. It was pretty neat. We talked to about 6 or so classrooms around North America, and they have a live YouTube feed as well. So there's people posting questions online.
Wow.
Yeah.
That's cool. So it's not your typical.
When we do a
thing.
live interaction, it's normally one-on-one with a particular classroom.
Right.
This we really do bounce around the whole of North America.
Wow.
Yeah.
That's cool.
So I don't know if the science team have got a moment. I was just going to throw them one question that came in on Nautilus Live that seems pretty good actually. And it's talking about really what you guys are looking for when you're sampling away from the main vent flow. Because obviously if you sample the flow coming directly out of the vent, then it's as far as possible 100% vent fluid. What are you kind of looking for when we kind of move around the vent and make these measurements?
The reason we sample away from the vent fluid is to get more of the background seawater or more of the diffuse flows in this area, because there's a plume that's caused by these vent fluid mixing in with the seawater around it. So we kind of want to see how it disperses and how fast it disperses.
Okay. No, that's a good answer, Eric. Thank you. And I guess as well, we see that's important because we see most of the life away from the direct vent. It's where the water has actually had the opportunity to mix with the seawater.
That's correct, because there's a lot of nutrients in that flow. But when it's extremely hot, say over 120, that would generally not allow microbes to grow because it denatures proteins and such.
That's right, yeah.
Sample stopped.
Roger.
End flow count 78025. End volume of 16.3 at a flow rate of 3.3 liters per minute.
Can you repeat the volume, the final volume?
16.3
16.3.
liters.
Yeah, copy. Thanks.
And the temperature was just 2.2 to 3.44.
All right, I want one more hot sample.
One more hot?
One more hot sample and then we're done.
Roger. That sounds good to me.
So similar to like the first time we started, we're gonna get into that point source, close to the point source.
Roger.
Data we're on S12.
Yep, that's right.
How hot do you want there, Eric?
I want as hot as I can go without melting the super sampler.
So 120, a little bit lower. Video, can you push in a bit?
Yep. I'm gonna set my temperature limit to
Roger.
120.
As your upper bound?
Yeah, actually I'm gonna make that 115 since it kind of lags.
Okay.
And the lower limit, I think I'll put 50.
It looks like the current has shifted.
So,
Definitely.
Yeah.
yeah.
Can I get another ship move? 5 meters. Let's do that 260 again, same one as before.
Copy.
Eric, how does this temperature read out to you?
Bridge nav.
It's 7 to 8 degrees. I think we're in front of it.
Okay.
It's getting a little hotter. 48, 73, 88, 90,
I'm frozen here.
83,
One more step, please.
81. $66. Can we push in just a smidge?
Metric smidge?
These are real terms, guys.
I expect to see smidge in the paper.
Are you talking about video or?
Attempts dropping.
No, I think he was
The
talking.
temperature
He was talking to me.
Okay.
Yeah, I'll let you know if I need any video zooms or
Yeah.
anything.
What are you getting, Michelle?
It dropped from 90 to the 20s.
Yeah, mine's dropping too.
Roger, understood. We'll come a little bit towards us again then.
Yes.
Holding here.
60, 57.
IGT's in the 30s.
Roger. What is yours reading, Eric?
55, 60, 72.
All right. You want me to go any more or just stay here and let it sit for a bit?
I'm gonna start to sample, but I will probably ask you to move it. And if we get out of colder flow.
Okay.
So have you started sampling?
Yeah, just start sampling.
For those of you on Nautilus Live, all of these temperatures you're hearing read out are in degrees Celsius.
Getting a little cold.
Okay. Let me know if you need me to shift.
49, 47, 45. It's dropping.
Okay.
IGT's in the teens.
Yeah, it looks like the flow went a little bit away from us. I'll just come over. All right, try it. Let's try that.
72, 76, 90, 91, 89, 99, 100, 102. This is good for now.
Okay. Looks like the current's being steady in one direction.
Don't jinx it.
I know. It's going to shift now towards our face.
We're still 114, 117.
For those of you following on Nautilus Live, Hercules is currently zoomed in on one of the hydrothermal vents that make up the Seacliff hydrothermal vent site. We are currently sampling the vent fluid that you can see as the shimmering liquid on the Hercules main camera view there. The blue wand is the edge of the sampling device. In the background you can see some of the microcolonizer experiments, those orange cones with numbers on, that we'll be retrieving a couple of those later today to see over the past few days how different species of microbes may have colonized some of the substrates we put in there. The Seacliff hydrothermal vent site is 2.7 kilometers under the ocean. It's part of the Gorda Ridge marine feature where the Pacific and the Gorda plates meet each other. This whole site and the Nautilus floating above it are 180 kilometers approximately west of the North American coast where California meets Oregon. We've got a big long day ahead of us today, diving I think well into the evening, so there'll be plenty for those of you on Nautilus Live to follow along with. We always appreciate your questions and comments on Nautilus Live, and as the pace of operations ebbs and flows during the day, we'll do our best to kind of bring those into the discussion.
Let's bring it up a smidge. We're
Roger.
getting pretty hot temperatures on this IGT.
Okay, understood. Coming up.
Dropping.
How's that?
That's good.
Might have gotten you a little bit out of the flow. Let me know if I need to reposition.
Still looking pretty good.
Roger.
IGT's at 133.
Let's bring it up a little bit more.
Okay, understood. Let's try that.
IGT's at 107.
I got 75. Minute and a half left.
So Nicole, what does the dive plan look like from here on in?
So I believe that this is the last super tube, right, Eric?
Yeah, this is the last one I'm going to take.
Okay. And then after that, we're going to pick up a rock for Shannon in this area, and then leave a marker where we pick up the rock.
Uh-huh.
And then set up, we're going to actually get to the site where we're going to pick up the colonization chambers. I guess that's this. We
Yep.
are there,
Yep.
yes. So we'll pick up the colonization chambers and then go and do some mapping with the high resolution sonar on Hercules.
Cool.
And then our next watch tonight, because we are gonna have another watch today, will be hopefully a geotransect by the time we're back here.
Yeah.
Okay.
Let's do it.
Sample.
Some late night subsea discovery.